When working in Combine, we have to be aware of what queue we're doing our work on. And Combine can work with many different sort of flavors of using different threads or different queues. And we often use these words interchangeably. And when we're doing this in iOS development, we often are using GCD, which means we're using a dispatch queue, or we're using operations, which is kind of a higher level concept. And operations can have dependencies. They can do their work in parallel or serial. This is kind of a higher level version of this. We don't often use threads directly. In addition to that, we also have the run loop. And this is used for working with kind of short timers like delays and debouncing and things like that. So Combine calls all of these things schedulers. It's sort of a unified concept that will talk about where the work is going to be done. And we've already seen a few examples of this. For instance, if we use timer.publishEvery, we pass in a time interval, and we have to tell this what run loop is going to be used to keep track of this timer. And often we'll use runloop.main unless we have something else that we need to use that's more appropriate. There's also runloop.current, and run loops have their own run loop mode, which usually is common or default. So we could say that in the default run loop mode, this is usually what we use. But we can read up on the run loop documentation to see the nuances of how these things might change. That's the example of using a timer, which takes a run loop. But we also have things like, let's say we want to delay. Here I can delay for some sort of time period, so let's say 5 seconds, and I have to specify a scheduler. Normally when we dispatch queue.main.async after, we've already specified the queue. And this one is kind of in reverse. We're specifying the delay, and then we're specifying kind of how that work should be run. And so here, when we're asked for a scheduler, I can give it any of these things. I could say I want to use operation queue.main or dispatch queue.main, or a global one if I want to do that work in the background. And then similarly to that, we also saw debounce, and debounce is very similar. We take some seconds and then a scheduler for how to deal with that work. So if I run some code here, and I say sync, and let's say I just don't care about the value, but I do want to know what thread we're on. I could say thread.current and maybe print thread.isMainThread. And if we run this, we'll see that we get the main thread out. So we subscribed to this, and it emitted a value on the main queue because we're on the main queue, and it calls this block on the main queue. So that all sort of makes sense. Now, if we were to take the same example and use this in a dispatch queue.global.async, and we do the same thing, now we're not on the main queue because we just did all the work on a background queue. So Combine will kind of honor whatever queue you're on for the most part. However, there are some differences here. So one of those differences is when we're using a URL session. So I'll get URL session.shared, and we want to do session.dataTaskPublisher for URL. And I'll make a quick URL here. And at this point, I don't care about any kind of error. So let's just say assert no failure. And then we can sync. And again, I don't really care about the output. I just want to know what thread we're on. So here I'll print thread.current and print thread.isMainThread. And we're going to have to hang on to this so it'll stick around. So let me put that in a cancelable. Okay, and as you can see, even though we started this work, we queued up this work on the main thread. By the time sync gets called, it's on the background thread. And that's because DataTaskPublisher is emitting its events on a background queue. And because this is networking, that's sort of expected. We want to do the networking on the background queue. And when it calls back, it's our job to maybe do further processing of that data or jump back onto the main queue when we're ready to update the UI. So this does pose a problem. How do I update the UI as a result of this call? And we could do this, but this is kind of a clunky solution because we would have to kind of do this everywhere. And so in this module, we're going to be talking about schedulers and how to influence what queues our code is run on. Okay, let's take a look at the first of the operators I want to talk about, and that is subscribe on. Subscribe on allows us to influence what queue is used when we subscribe to a new pipeline, or if we request new values or cancel that subscription. So let's start with an example. I'm going to start with a publisher that just does this, and we'll grab the value here. and then we'll print out the value. And I also want to print out what thread it comes on. So here we're going to say maybe X is X, and then we can say thread is, and then I'll just output thread.current. Okay, and we're going to do some asynchronous work. So I'm just going to sort of store this in a cancelable so it doesn't go away as we do that. And you can see we got our value, and the thread is the main thread, and that's because I subscribe to this on the main thread, and just will just emit its event right away. And so it all happens on the main thread. Now, if I tell this to subscribe on a different scheduler, here I can use maybe dispatch queue.global. Now I would be doing this all on a background thread. So even though I'm on the main thread, when I start the chain, the subscription is created on the background thread. And what you'll notice is that from that point onward, by default, the publisher is going to publish its values on the current thread, which at this point is dispatch queue.global. So you can see it doesn't say main here. Now, one thing we can notice about that is if I say start here, and then take this value and maybe say done here, what we can notice is that this is emitting a value in the background, kind of in line with everything else. Okay, if I get rid of this, now we can see that it's done kind of in line and we're on the main queue. Okay, so let's add a little bit of a sort of obvious delay here. So I'm going to sleep for 1 second inside of this map. And then here I want to print out that we're mapping, and then I want to show that I want to show what thread we're on. So I'm just going to copy this code here and put that here. Okay, so without the subscribe on, we run this, we get the start, and we kind of have to wait for a second for the map to happen. Then we get this guy, and then done. And all of this is happening on the main queue. So now if I say that I want to subscribe on the global queue, notice that the first map thread is happening on the main queue, but X from that point downward is happening on this queue. So now what will happen if I tell the map to subscribe on the global queue? So I've just moved the subscribe call upward. So running that, we can now see that this subscribe happens asynchronously, and from that point onward, everything is done asynchronously. And so we get start and done kind of immediately. And then we have the work happening. And both of these blocks are executing on the background queue. So there's some nuances here to how this works. And to point that out, I want to sort of talk about what happens if I have both of these. So if we run this, we get the same results as last time. And it's not quite obvious why. So let's walk up the chain backwards. So we start with the subscriber. And the subscriber, we're saying to subscribe on everything up here on the main queue. So it's like, okay, I'm going to subscribe to this on the main queue. Well, map then says I'm going to subscribe to everything above it on the background queue. So the actual subscription happens on the background queue. And from that point onward, now it flows downward, and it's ignoring, these because these only happen during the subscription part of it. So from that point onward, we're on whatever queue was kind of last set on the subscribe call, as you can see here. So that's why both of these are with this global queue. If I flip them and used global here and set main here, then we would be subscribing on the main queue. And now there's an interesting nuance here that the queues themselves are done, but because we sort of hopped onto the global queue to do the rest of the subscription, this subscription happens asynchronously. And as you can see, we get start and done like this. So there are some nuances to pay attention to here, but really you only want to use this if you know that the work being done for creating the subscription is maybe substantial or needs to not block the UI, then you'll want to use subscribe on. But it's also important not to ever use that to influence what is used down here. Because as we saw, by default, most publishers will just emit their values on whatever queue is the current queue. But that's not always true. As we saw in the last video, URL Session Data Task Publisher will always emit it on a background queue, and we can't use subscribe on to influence that. Subscribe on really only influences it in the up direction. Going up the chain is influencing what we use to subscribe to the stream, and once that's done, it will just sort of play out on whatever queue it's on and whatever queue the publisher wants to emit its values on. So now let's talk about the probably more common approach that we're going to use to control our threading, and that is with receive on scheduler. Now, receive on is going to control what queue the values are received on, and that's going to control everything downstream from it. And so this one is usually what we want when we want to control, which queue is used to receive these events. So if I say receive on, it doesn't matter what the upstream is going to be doing. And so that's going to guarantee that everything downstream from it is on the queue that you expect. So here, if I change this to dispatch queue.global, you can see that I'm on a global thread. And so this is what we would typically use when we're dealing with networking. Is after the networking and data sort of transformation or whatever is done, any kind of decoding logic, we then receive on dispatch queue.main to deliver this publisher to someone else. So if, for instance, if you're going to be using erase to any publisher, then you would probably kind of add these two things at the end of the chain and then return it. And then the caller doesn't really need to care about it, and you can guarantee that it'll be called on the main queue. And one way that we can kind of see this in effect is if we have our start and done kind of dividers, and we can kind of see what's going on here. One thing we'll notice is that, and this is actually calling dispatch queue.main.async in any case. So what's happening is we get done before we get this call here, even though this is all happening immediate. Because of this, it's actually it's not checking what queue it's on. It's always doing this dispatch queue.main. If I remove that, you can see that it's done in line. We get start, then the sync, and then done. And if we wanted to do something like delay for maybe, 1 second, and then use dispatch queue.global here, then we could say, okay, now from that point onward, I want to receive the results downstream on the main thread, and it works just like you'd expect. So this is usually the approach that you're going to do to guarantee that anytime we're doing any kind of UI work, we want to make sure and do it on the main thread. And then anytime we're doing any kind of bulk processing or decoding of data or interpreting or any kind of complicated logic, we want to make sure that that's done on a background thread so it doesn't block our UI.